I'm in our teaching laboratory where today we're going to be performing an experiment in which we find the half-life of silver. Here is one of the silver foils that we're going to be using. Right now it's not radioactive because silver, when you dig it out of the ground, comes in two different isotopes, silver 107 and silver 109, and neither of those isotopes are radioactive. So our first step is going to be changing those isotopes to make them radioactive. To do that, we're going to be using the neutron howitzer. No, it's not that kind of howitzer.
A neutron is,
The bullet.
yes, the bullet.
Okay, maybe it's something similar. Inside of this machine, there is a neutron source which is going to bombard our silver foils, which I'm putting into the howitzer now. At the center of the howitzer is a neutron source. Americium-241 gives off an alpha particle, so that means every so often it spits off 2 protons and 2 neutrons and becomes Neptunium-237. That alpha particle interacts with another atom inside of the source, beryllium-9. When beryllium-9 absorbs the alpha particle, it becomes carbon-12 and a neutron. This happens to the tune of about 1,000,000 neutrons per second. Those neutrons travel down the tube towards our silver foils and interact with our silver 109 and silver 107 atoms. When silver 109 and silver 107 absorb those neutrons, they become silver 110 and silver 108. And from this point forward, they will be the stars of our show. Let me bring back silver 108. Silver 108 is a beta emitter, which means somewhere inside of there is a neutron that wants to become a proton. When that happens, it spits off a beta particle and becomes cadmium 108. The exact same thing happens with silver 110, except for it happens at a different rate. We'll be measuring the amount of beta particles that come off of each of those atoms in our silver foil, and from that measurement, we should be able to find the half-lives of each. Once the silver foils come out of the howitzer, they are radioactive, and we're ready to count the radioactivity that comes off of them. With this machine, we'll count how many beta particles come off of these silver foils in 10-second increments. You'll see that I started a stopwatch and the machine at the same time so that we know from the stopwatch how long it's been since we've started our initial count. That's very important for this experiment because we want to know how long it'll take before half of the silver isotopes have decayed. I'll continue taking 10-second counts at the beginning of the experiment because at this time we have both silver 108 and silver 110 isotopes which are decaying at the same time. Later on in the count, one of the two will have decayed away and I will only be counting for one of them, the longer lived one. So we won't need 10-second counts, I can switch over to 30-second counts. And at this point I can go ahead and speed up the video and we can get that data over to you for you to find the silver half-lives.